We are Team 9. This is our robot. The entire chassis is 3D printed in 3 parts. We can take it apart, get inside. There's little screws that hold it on. Some of our design features that we're proud of is our ball collecting toilet bowl. It's very effective. You can be pretty much anywhere on the ball pickup and it'll catch it. Here is our ball drop-off mechanism. It's a little slider, and it's held in tension by some rubber bands that just push it right back into place every time. So you can do this as many times as you need, and it comes right back to the original position afterward.
We designed this whole base in 2 iterations. This is the first iteration. It was working really well when we were using it. And then we redesigned it a little bit, added some extra rounding, and separated it into 3 parts. Added extra bosses, extra holes for wires, and overall it ended up being really, really good. And we have special slots for all of our sensors and our PCB, bosses for our drivers, even a slot for our pick right in there. And there's even sort of a press fit for the battery, so the battery stays in there snug, even though there's nothing other than friction holding it right there.
Another thing that our team did that was kind of interesting, a lot of our sensors are analog. So we're using the Sharp sensors for our proximity and then our QRDs. With everything running on an analog signal, it's actually pretty easy to program in our code, just measuring essentially the voltage response that we get, and makes our Canyon navigation super, super consistent. With our QRD array on the bottom, we didn't implement full PID controls, but we partially did, in the sense that when our robot detects a line on one side, it will gradually increase the speed of that wheel so that we can track the line more smoothly and we won't get as much jerky motion.
Sweet, so this is the PCB that I helped design for the robot. What's super nice about this is that all of the circuitry in between sensors and the pick and power, it's all integrated in this PCB right here. If you can look at the robot right here, we also have it stowed away in a nice little spot right here. So most wiring is contained in this little cavity. This enabled us to avoid having loose connections and things just falling out of place, and everything was very organized. So it's easy to diagnose some of the problems that we had with wiring.
If we were to go back and do it again, I think something we'd do differently is focus on speeding up the robot on the line and in the Canyon, and then potentially also weight distribution and weight saving on the chassis. Something we noticed was the front end of the robot would lift up when full current was applied to both motors at the same time, and we think we could get it more consistent if we navigated that a little bit better. But overall, especially our ball pickup and drop off was incredibly consistent, and we navigated the course.